We'll finish our course on financial mathematics by discussing present value and future value. The basic question we wish to address is simple. If I have a certain amount to invest today, how much of it should I use to reach a value tomorrow under known interest conditions? In this situation, I have a certain principal that I would like to invest in order to get a certain value in the future. I know that, for example, under the compound interest model, my initial principal will multiply by a factor corresponding to the rate, the number of times I compound, and the time in which I invest my money. The amount it is worth depends. The amount of my investment depends on these quantities. Okay? We can consider the future value of our money today by computing how much it will be worth under these conditions in the future. This gives us a sense of I can either spend my money now or I can invest it in a certain way and get more of it in the future. Let's look at a few examples of computing this. Suppose I wish after 5 years to have $20,000. If I know that I can get 5% interest on my money, how much should I loan out or invest today in order to be able to meet my goal? Well, I followed the model of compound interest, compounding yearly. So according to this, whatever amount I get is going to be the principal times 1 plus my rate divided by the number of times I compound to the NT. So here, the principal is unknown. I want to determine this. The amount that I want at the end is $20,000. I'd like to end up with $20,000. The rate is fixed at 0.05. The number of times I compound is once, since I compound yearly, and t will be 5. So I have to solve the equation 20,000 equals p times 1 plus 0.05 divided by 1 to the 1 times 5. So dividing, I get that p is equal to 20,000 divided by 1 plus, let's write this as 1.05 to the 5th, which can be shown to be equal to $15,670.52. So I need to invest a little less than $16,000 today to have $20,000 in 5 years. And this was under the model of compounding interest yearly. We can also look at how much we would need to invest under the model of continuous compounding. Here, the model is a bit simpler. The amount in the future is equal to the amount today times e to the RT. So again, A is known as 20,000. This is how much I need in the future. The rate is 0.05 and t is 5. So 20,000 should be equal to p times e to the 0.05 times 5. Dividing 20,000 divided by e to the 0.25. This is equal to about 15,576.02. So as a remark, I need to invest less under the model of compound interest than I do, under continuous compounding than I do under the model of compounding yearly. This makes sense. I need to invest less with compounding continuously because I earn more on my initial investment with compounding continuously. So this is all very nice. This tells me that I can earn money on my investment. This needs to be measured against something, though. This needs to be measured against what's called inflation. Inflation is an important economic concept. It essentially says that the value of money decreases over time when everything else is equal. This is because the price of goods and services tends to increase over time. This is evident to anyone who has, for example, looked at the price of cars over the past 20 years. They have increased. Look at the price of a car in 1920 versus now. they're different by at least a factor of 5. This is because even though we have advances in technology that make production easier, the value of money has simply declined with time. Prices have gone up. So if you make an investment, you need to think about, can I buy the same things in the future as I can today? Okay, so I will say that inflation is very well studied in economics, still has some mystery about it. Not everyone is sure how to control it. We will not discuss it in anything except a mathematical context. We'll simply try to understand how much something will cost in the future given a certain rate of inflation. So let's look at an example. Suppose a house cost $10,000 in 1950. Supposing that inflation is 4% annually, what would the cost be in today's dollars? What it means when we say that the inflation is 4% annually, we mean that every year, inflation has gotten 4% higher. That is, the price of goods has gone up 4%. So the model here is the future amount is the old amount times essentially the same as the model of compound interest, which allows me to sort of accumulate this rate. So R over N times T. So here the principal amount is the original house cost. N is once, since inflation is a yearly rate. It's a 4% inflation. And then how long is it? Well, it's 2017. So I do 2017 minus 1950. And I'm just substituting everything into the formula here. And this winds up being approximately $262,834.90. So a $10,000 house went up to over $260,000 just because of inflation. So if you had made an investment in the 1950s, you would have a lot more cash now than you would have had in the 1950s. But the question of whether it buys the same amount needs to be tempered against inflation. Maybe you had $10,000 in the 1950s and you made investments, and now you have $250,000. It sounds good on paper, but it doesn't even buy the same amount because of inflation. So the actual value of your money is less, even though you have more of it. This is just a basic overview of these concepts. If you find these things interesting, consider studying some macroeconomics. These types of concepts are very well studied and have quite interesting corollaries.